notes for lesson 5.3, solving quadratic equations by finding square roots. In lesson 5.2, we looked at solving quadratic equations using factoring. The second method that we are going to look at is using square roots. Before we get into the solving portion of this lesson, we're first going to review different parts of radicals, and then we're going to look at different properties to simplify square roots, and then we're going to look at how we solve equations with square roots. So parts of a radical, the first thing is our radical symbol. And a lot of you may think of this as a square root, and in most cases it will be the square root. The number on the outside of our square root we call the index. The number inside the square root is called the radicand. And the whole thing together is called our radical. Again, you are probably familiar with seeing just the square root, but we can also have different numbers as our index, and that will change the radical for us. Now the asterisk says that if the index is not written, then it is automatically a 2. And again, that's the square root symbol that you are probably most familiar with seeing. Now there are different properties that we can use with square roots to simplify them, to write our answers in simplest form. The first one is our multiplication property, and that just simply means that if we have the square root of two numbers that are multiplied together, we can split those numbers apart and take the square root of each. So the square root of a times b is the same as saying the square root of a times the square root of b. Again, a and b are positive numbers. So whatever radical you have, if you're multiplying underneath the radical symbol, you can split those apart and multiply the root of each. The division property is similar. If we have the square root or the root of a fraction, we can split this into the square root of the numerator over the square root of the denominator. Again, a and b are positive, and b cannot equal 0 because we can't have a 0 as the denominator. So we can use these two properties when we're simplifying radicals or simplifying square roots. Another key thing to remember when we're simplifying radicals is that you need to find the prime factorization. You may recall this as being called a factor tree. I'm going to show you a different method of getting a prime factorization that I think makes a lot of sense. So again, we can either use our multiplication rules for square roots, our division or fraction rules, or prime factorization. We're going to look at an example of each of those below. So example 1, part A. Again, we're simplifying each of these radicals. So the first one, notice we have a fraction. We have the square root of 8 over the square root of 2. If you remember our division property, we can take the square root of this whole fraction. So this is the same as the square root of 8 over 2. 8 divided by 2 we know is 4. So this is the same as saying the square root of 4. Now we know that the square root of 4 is 2. So the square root of 8 over the square root of 2 can be simplified to 2. For part B, we have the square root of 8. This is where prime factorization comes into play. Now the method I want to show you is what we call the birthday cake method. So we're going to start with our number at the bottom, so that's 8, and we're looking for prime numbers that are divisible by 8. So we know that 8 is divisible by 2. Now remember, prime numbers are numbers like 2, 3, 5, 7, 11, 13. So we're looking for prime numbers that are divisible by our number. So 8 divided by 2 we know is 4, so you're going to write your answer above. And we're going to do that same step again. We're looking for a prime number that is divisible by 4, and again that's 2. And our answer again is 2, because 2 times 2 is 4. And then we're looking at 2 that can be divisible by 2, and our answer is 1. Now the reason we call this the birthday cake method is because you should always get a 1 at the top. You might think of that as your little candle on your birthday cake. So our prime factorization are the numbers along the left-hand column. So if we rewrite this underneath the radical, we have 2 times 2 times 2. Now, to simplify this radical, we know that the index is 2. We know it's a square root, so we're looking for groups of 2. So we know that there are 2 2's will make up one group. Whenever we have a group, we know that that number goes outside of the square root. So this is going to be 2 times the square root of 2. So if we have a group of of two numbers that are the same, we're going to take one of those and write it outside of the radical. Because if you think about this, 2 times 2 is 4. We know that the square root of 4 is 2, so that's why it comes out front. So our simplified answer is 2 square roots of 2. For part C, we're simplifying the square root of 24. We're going to do the same thing using your birthday cake method. So we're going to start with 24. Again, we want prime numbers that are divisible by 24. Now I know it's even, so I know it's divisible by 2. If I divide 24 by 2, I get 12. We're going to do the same thing with 12. Again, it's divisible by 2, and we get 6. Again, 6 is divisible by 2, and we get 3. 3 is divisible by 3, and we get our 1 that we are looking for. So again, our prime factorization, or all of our prime numbers are on the left-hand side. So the square root of 24 is the same as 2 times 2 times 2 times 3. Again, we're looking for groups of 2. So we have 2 2's. So again, we're going to bring a 2 outside of our radical. Now notice we have a 2 and a 3 left underneath the radical. They're not in groups. So we're just going to multiply those together, and they stay underneath the radical. So we have 2 times 3, which is 6. So our simplified answer is 2 square roots of 6. Now for part D, we have the square root of 6 times the square root of 15. For this one, we can use our multiplication rule. So we can take 6 and 15 and multiply them together. So this is the same as saying the square root of 90. Now we can do the same thing that we did in parts B and C. Use our factorization, our birthday cake method. So 90, I know, is divisible by 3. 90 divided by 3 is 30. I know that 30 is also divisible by 3, and I get 10. 10 is divisible by 2, we get 5. 5 is divisible by 5, and I get 1. Again, you know that you're done when you have a 1 at the very top. So my prime factors here are 3 times 3 times 2 times 5. Again, we're looking for groups of 2. We have 2 3's, so we're going to put a 3 outside of our radical, and underneath we're left with 2 and 5. We're going to multiply those together to get 10. So our simplified square root is 3 square roots of 10. To completely simplify a radical, there cannot be a radical in the denominator. So to get rid of a radical in the denominator, we do what is called rationalizing the denominator. We need to multiply the fraction by 1 because we know that that does not change the value. Now, any expression divided by itself is equal to 1. So we know that 3 divided by 3, or 3 over 3, is 1. So we can multiply something by 3 over 3, and it's not going to change it at all. So to get rid of a radical in the denominator, we're going to multiply the numerator and the denominator by the radical in the denominator. And then if possible, we're going to simplify. So let's look at our first example. We have the square root of 2/3. If you remember your division property, we can split this into the square root of 2 over the square root of 3. Now notice we have a radical in the denominator. Remember, we cannot have a radical in the denominator, so this is where we have to rationalize the denominator. So to simplify or get rid of that radical in the denominator, we're going to multiply by the radical that's in the denominator, which is the square root of 3. Now whatever we do to the denominator, we also have to do to the numerator, so that's why we have to multiply by the square root of 3 over 3. So if we use our multiplication property, the square root of 2 times the square root of 3 is the square root of 6 over the square root of 3 times the square root of 3 is the square root of 9. Now we know that the square root of 9 is 3. The square root of 6 cannot be simplified because it's just 2 times 3, so we don't have any groups that we can factor out. So our final simplified answer is the square root of 6 over 3. For part B, we have the square root of 2 over the square root of 11. Again, notice we have our radical in the denominator, which we cannot have, so we need to get rid of that. So again, we're going to multiply by the radical in the denominator, which is the square root of 11. So we're going to multiply by the square root of 11 over the square root of 11. The square root of 2 times the square root of 11 is the square root of 22. Square root of 11 times the square root of 11 is the square root of 121. We know that the square root of 121 is just 11. So we get the square root of 22 over 11, and that's our simplified fraction. So again, if we have a radical in the denominator, we have to multiply by 1 or with that radical in order to completely simplify. Now that leads us into solving quadratics. Remember, there are two forms that we have looked at for solving quadratics. The first is factoring. Now there are many different ways of looking at quadratics. There are many different ways of solving quadratics. So if we are solving by factoring, our equation must be in the form ax squared plus bx plus c. If we don't have a trinomial in that form, then we can't factor it. Now factoring will not work for all polynomials. There are some polynomials that cannot be factored, so factoring will not always work. The second form that we're going to look at now is square roots. In order to use a square root, it must be in the form ax squared equals c. Now notice there is no x term, or x term is equal to 0. So this will not work if your x term is not 0. So again, you cannot have an x term in order to use square roots. So let's look at our examples. So for part A, we have 2x squared plus 3 equals 27. Notice we don't have a single x term, so we're just going to isolate the variable just like we would solve an equation. So we're going to subtract 3 from both sides. We get 2x squared equals 24. Remember, we want to get x all by itself, so we're going to divide by 2. So we get x squared equals 12. Now if you remember from Algebra 1, and if not, the inverse of a square is to take the square root. So to get rid of a square, we square root it. So we want to square root x squared. Whatever we do on one side of the equation, we also have to do on the other side. So we also have to take the square root of 12. So this will give us x equals. Now when we take the square root, we have to remember that there's two different answers. This could be plus or minus the square root of 12. Because if we square something, it can be a negative times a negative, which will still get us a positive. So we always have to look at those two cases. Now the square root of 12, we have to make sure and simplify it if we can. So we're going to use our prime factorization that we talked about before. So we can divide 12 by 2, and that will give us 6. 6 is also divisible by 2, which will give us 3. 3 divided by 3 will give us the one that we're looking for. So we're looking for our groups of 2. So the square root of 12 is 2 times 2 times 3. We have a group of 2's again. So x equals plus or minus. Our 2 comes out front, and the square root of 3 stays the square root of 3. So our solution for this quadratic equation is x equals plus or minus 2 square roots of 3. For part B, same thing. We want to isolate our variable, isolate our square. Now notice we have a 1/4 that is multiplied by our parentheses. So to get rid of a fraction, remember we have to multiply by the reciprocal. So the reciprocal of 1/4 is going to be 4. So we're going to multiply by 4 on both sides of our equation. So this gives us x minus 8 quantity squared equals 28. Now notice in our parentheses it is squared. So next we want to get rid of that square because that's what's on the outside of our equation. So we're going to take the square root of both sides. Again, that's going to get rid of our square for us. So we're just left with x minus 8 equals plus or minus the square root of 28. We're going to do the same thing. We have to look at our factorization. 28 is divisible by 2. That will give us 14. 14 is also divisible by 2. That will give us 7. 7 is divided by 7. That will get us our one that we're looking for. So we have x minus 8 equals plus or minus 2 square roots of 7. Because we have a group of 2's, so that goes on the outside. The 7 goes on the inside of the radical. Now we're not quite done yet. We still have our minus 8 that is attached to our x, so we're going to add 8 to both sides. Now we have to think of radicals like terms. We can only combine radicals if they're the same. So if we have a constant and numbers with radicals, we cannot combine those. So this is the same as saying 8 plus or minus 2 square roots of 7. So our final answer is 8 plus 2 square roots of 7 and 8 minus 2 square roots of 7. Now you can write it with the plus or minus, or you can write them separately. Either way is correct. So again, now we've talked about 2 different ways of solving quadratic equations. The first is factoring, which again will not work for all polynomials because not all polynomials can be factored. The second method is square roots. Again, you can only use square roots if you do not have that x middle term. In the next sections, we're going to look at a couple other methods for solving quadratics as well.